Hey guys, my name is Sing Young, and I'm currently in my fourth year, and my major is electronic engineering. And last year, I did a project on capstan design with my teammates, and today I'm here to give you guys a presentation about what I did last year, and I hope you guys like my presentation. And the main theme for our capstan design was the mechanism of power distribution in South Korea. We actually made an electrical circuit, and as you can see in the left, there's a generator, which obviously generates electricity. And by using a transformer, we were able to convert the electricity. And also, by using a rectifier, we were able to change alternative current into direct current, which means AC to DC. And by using the direct current, we were able to light up the light bulb, which is an LED. And the LED actually stands for the energy we get in our houses, the electricity we need for charging our phones, or the electricity we need for turning on our TV. Yeah. So let's start with the transformer first. And this is a basic diagram of a transformer. And I thought we just needed to control the radio of turns of the coil. And we all thought it was a piece of cake because in theory, making a transformer is really easy, but we found out we were really wrong. So we got ourselves a magnet and some copper wire, and we tried to make a transformer out of it. And the result was we weren't able to get any sine or cosine graphs. And did you guys notice anything weird about this? A ferromagnetic material is not a magnet. So what is a ferromagnetic material? A ferromagnetism refers to a phenomenon in which all spins are aligned in a specific direction by themselves by interaction between spins and a magnetic body. Examples of ferromagnetic bodies are iron and cobalt. And so we decided to use an iron knot to make the transformer. And this is the transformer we made from the iron knot. And the result was we weren't still able to get any sine or cosine graphs out of it. So we were really frustrated. We didn't know what was wrong. So we decided to cross the line. And so we got ourselves a plugger and we attached the transformer to the 220 voltage plugger, and there was a loud explosion in our lab. And as you can see, there is some burnt in our transformer. It's because we applied 220 voltage, but there is almost no resistance. So due to Ohm's law, if the resistance is really low, the current is really high. So the transformer weren't able to withstand the high current, so it's burnt here. So we gave another try with a thinner copper wire, and we actually made some transformers out of it. And we were able to get some sine and cosine graphs. And this is our final transformer we used for our project. And when we applied 60 hertz, we were able to get 448 millivolts. And when we applied 3000 hertz, we were able to get 2.7 volts. This is all RMS. And when you applied 1 megahertz, we were able to get 6.9 voltage. So these are the numbers we actually got from our tests. And the reason for this is because voltage equals 4.4 for n pi frequency. So if the voltage is constant and there's a low frequency, there's an increase in magnetic flux, and the voltage is constant and there's a high frequency, there's a decrease of magnetic flux. So when the magnetic flux becomes larger than the rated state, the magnetic saturation occurs, and accordingly, the excitation current increases significantly. This increases copper loss and increases iron loss due to increased hysteresis. Therefore, you have to put in the right frequency so that proper magnetic flux is generated. So this is the turn radio, and we were able to get the right frequency out of it, as you can see in the picture. And the reason for us for trying to get the higher voltage is because with the higher voltage, we were able to lower the power loss. So that's the reason. And we also made a half-wave rectifier, and the picture on the left is our theory, and this is our test result. And we also made a full-wave rectifier, and there's a theory in our left. And we actually made a circuit to the breadboard using the breadboard, and this is the graphs we were able to get. And the picture on the left is without the capacitor, and the picture on the right is with a capacitor. And as you can see, alternative current is changed into direct current by using the full wave rectifier. So our test was successful. And also, eco-friendly energy that does not create carbon is attracting these days, attracting attention these days. So we actually made a wind power generator. You see, we also use some glue guns and some magnet, and we were able to make a wind power generator. And due to Faraday's law, by rotating the magnet, it changes the magnetic flux of the coil, which is here, which eventually creates induced voltage. So yeah, this is making the wind power generator. And this is our final completion of our project. And thank you.